Word up. Nationwide hated. Nickel plate.
Sequel or death? Yo, son, what are you going to choose? Yo, check it. This seminar is filmed at Carnegie Mellon University. Thanks a lot, Google.
Welcome back, everyone, to our seminar series, Sequel or Death. I'm obviously not Andy. Andy's sick this week, so I'm taking over for hosting. And today we're joined by Tobias Brandt, who is a PRQL contributor. So Tobias is a recovering physicist who traded the abstract world of TQFTs for the slightly abstract world of financial data and lived to tell the tale. He spent the last 2 decades on a global quest to tame market chaos, armed with a growing arsenal of data languages, SQL, Python, R, and yes, even Excel. Along the way, he's encountered enough null values from left joins to question the very fabric of reality, which naturally led him to PRQL. He's now a passionate advocate for simpler, more elegant data transformation. Tobias is joining us from South Africa. It's 10:30 p.m. there, which is quite late. So thank you, Tobias. And yeah, take it away.
Thank you, Sam. Thanks for that intro. And Andy, thank you very much for the invitation. I'm very excited to tell you about the work we've been doing with PRQL or prequel. And as someone who also follows a database oriented lifestyle, I don't know if it's a requirement for that to have like a intro track, but it's certainly something that resonates with me. So I kind of want to start on that note. And so without further ado, let's begin. All right, here we go. All right, so here's a little taster of prequel, and we'll get more into that later. But first of all, I want to begin with why do we feel the need for introducing yet another language? All right, so it all began with a post on Hacker News by one of our core maintainers, Max, in January 2022, with a proposal for a better SQL, which easily reached the front page of Hacker News, and we had a lot of interesting contributions. And I saw it at the time, and also then a few months later got involved myself, and we've been at it ever since. All right, so I'm come from a sort of data scientist, data engineering perspective, and I think that will come through the rest of the talk. And so what kind of matters from that perspective, which kind of like as a practitioner, is prequel is really aimed at complex OLAP type queries where you kind of want to work interactively, maybe do some exploratory data analysis. So what ergonomics matters, readability. I believe code is read more than is written. And also one of the key features is composability, extensibility, and also testability. So those are all kind of key aspects that we need for like in data work in like our day-to-day lives. Right, so SQL is 50 years old and it's endured for a long time. And the question we want to pose is, is it a shark that kind of has reached the pinnacle apex predator that has no need of further evolution, or is it a bloated dinosaur that's kind of one step away from extinction? Right, so let's first look at SQL the shark. SQL is the lingua franca of data. It's found everywhere from relational database management systems, data frame APIs like pandas or polars, except SQL, data lakehouse engines. And we at prequel, we believe there's 2 key aspects to that. So that's the relational model and the declarative nature. And I'll go into each of these first. So first of all, on the relational model, I think data is tabular. The slide I took from Hannes Mühleisen's inaugural lecture on ancient art of data management, and it's a tablet that was uncovered 5,000 years ago, and it recorded some early trade in hop and barley. So nothing much has changed, or what goes around comes around. And so I think data has been tabular for at least the first 5,000 years. And there's some interesting articles like the unreasonable effectiveness of SQL. What's interesting what I found, and I actually think it should be the unreasonable effectiveness of product types that is the cause of this, but hopefully I'll get back to that later on. All right. Then we obviously have this great paper, what goes around, comes around, and which reviews the first 50 years of SQL, or in this paper, the last 10, 20 years. But the relationals model has been around for 50 years, and I think from the conclusion of the paper, which I agree with, I think it's safe to say it's probably going to be around for the next 50 years as well. Then the other key aspect is that SQL is declarative, so that obviously gives the query optimizer a lot of opportunity to optimize your queries, and how to do its data retrieval, where to do certain operations. And like a key aspect of that is bring the compute to data, which especially in our this modern world with data lakehouses and cloud data warehouses is like a key aspect. And like just an example for that is that, for example, the predicate pushdown. So if you're doing a very complex query that only selects a small subset of the data, obviously you want to do your filtering as early on, as close as possible to the data before you push a lot of data across the wire. And I think that stands in contrast to like data frame kind of APIs and work, where if you're working in pandas or polars, where often all the data first has to be pulled down into your working memory on your node, and the processing gets done there. So I think that is also a key aspect that we want to retain. But now coming to SQL, the dinosaur, and early on in the seminar series, we had this talk by Victor Leis and Thomas Neumann on Towards Sanity in Query Languages, which is an excellent talk. If you haven't watched it already, I strongly urge you to watch it, and I pretty much agree with everything that was said there, and they sum up key points that, similar to myself, I think I'll recapitulate some of those with a more practitioner perspective. But just the one that I want to pick on here was on the relational calculus. And Thomas mentioned there that writing a SQL parser is no easy task, and it's complex language, and I think part of that comes from the relational calculus aspect of SQL, which, for example, in this example here is you have this global scope and all these different tails that get joined and pulled into the scope, and then get exposed in this select clause. So I think that is an undesirable aspect, for at least for the human, and from a readability perspective, because if it's difficult for the compiler to keep track of all of these things, for like a human reading the query, and when you're reading the select part, you're having to trace where certain things come from, it really makes it difficult for analysts working with the queries like this, if they're having to maintain and to really keep track of what's going on. So I just want to do a little detour here into relational algebra versus relational calculus. So if you do searches on the web, or you go to Wikipedia, you'll find something like this, that relational calculus is meant as a declarative language, whereas relational algebra is an imperative language. Or like another one I found, you have these two columns here, and it's often brought up that relational algebra is a procedural language. And Thomas also made that point that it looks imperative, but it actually isn't. And I would argue that almost by definition, because it's relational algebra, if it's an algebra in the mathematical sense, it's composed of functions, and we know that those are functional. So I think it looks imperative because it's repeated function application, but it's really functional rather than procedural or imperative, because there's no external state that isn't passed along in the functions. So I think a key distinction, it's a relational algebra is functional, and functional languages having a bit of a resurgence, and I'm a big fan myself, and I think that from that you can take that it's still actually declarative. So we're not giving that up at all by just sticking to relational algebra rather than relational calculus. Also, obviously, there's Codd's theorem saying that two are equivalent, and then some stronger things that a language just needs to be relationally complete to to get all the benefits that we get from like SQL or relational calculus. And I think with PRQL we have that, so you're not giving up anything in generality. All right, then the sort of next thing that we dislike about SQL is that the syntax is very patched and it's overloaded, particularly in the select clause. If you have a sum, for example, or some sort of aggregation, then like if it's in a window function, then it's you maintain the same set of rows. But if there's a group by later on, then it causes a reduction. So it's very overloaded syntax, and it just looks like really old and antiquated, like COBOL from the 1970s. But I think much more sort of substantial criticism is that it's not composable. And someone might sort of kind of say, no, it's not true. Look here, for example, this example here, you can compose SQL because you have nested from statements, but it's not composable in the same way as other languages are. There's no kind of good abstractions. And a tweet that I saw that I think that really kind of captured that nicely is that SQL queries are the single-use plastics of the code world. And in my practical experience, people copy and paste queries and try to modify them. There are no libraries of SQL code or SQL functions that lead to like reusability with hardened tested code. Then also SQL is not regular, and in the sort of syntax sense, and it's very difficult to learn. So Julia Evans gave this talk at Strange Loop in 2023 and sort of describing experience with a colleague and saying that how difficult SQL is to learn. And for us who've been using it for a long time, it's just kind of seems puzzling at first, like what's difficult about SQL. But actually it's because it has these clauses rather than like a sort of regular syntax. There you have to know that they have to go in a certain order, and we have a where and a having. So both of them actually do a filtering operation, but you need to have different keywords in different places. And then when you have window functions, it gets even worse, and you have to now you add qualify. And if you want to do some partitioning in the window function, then you need partition by, which actually is like a group by. So for a beginner, it's really difficult to learn and get on top of all the intricacies. And just her sort of conclusion was that you also kind of want to have when you're reading a program or sort of a query, you kind of want a chronological story, so like a logical flow from top to bottom. It doesn't mean that it has to be executed that way, but at least for the human, that sort of logically you kind of want a top to bottom flow. Then we also have the issue of dialect. So when I first started working in the financial markets, I was at a SQL Server shop, and then I worked for a big hedge fund in London where we used Oracle. And then it's fine. You just had one kind of particular syntax to learn. You could get good at that and become productive. But these days, as data engineers or data scientists, we often have to pull data from many different sources, and then you really get tripped up with all the different dialects, because what you're trying to do on Snowflake doesn't work on your local Postgres database. And so it's becoming a real hindrance for the working data scientist and data engineer. And then last, we have this issue of unclear semantics, which Victor talked about in his talk, which I think is also a big issue. I mean, that's not something that we've actually looked at much with PRQL, but we've had some discussions with Manuel Rieger from the National University of Singapore, and they're doing some work that's up for publication soon, also on differential testing of different database systems, and they've also documented many of these sort of inconsistencies across different dialects and different behaviors, much like Victor Leis documented. And so I think their call for a universal intermediate representation is a really great one. And I mean, I already had this slide which I put together on where I think sort of PRQL could fit in as like as a front end query language, or like a sort of human front end and text representation, which then like serializes to substrate, which gets sent to your query execution engine. And then I was very happy to see Victor also kind of had their proposal for sane IR and PRQL there. So I think it's yeah, very similar vision, and I yeah, really like wish them much luck, and I'll be watching closely as to yeah, what they produce there. And just to say that that's something that we're not looking to solve with PRQL. We're really just looking at the syntax level and making it a productive language for working practitioners. All right, so let's look at some alternative query languages. So yeah, Thomas presented SaneQL, and if you just look at this example code snippet, it's actually very similar to what you would get in PRQL. And so I've just taken that snippet and rewritten it in PRQL, and if you've kind of put that through our compiler, this would be the SQL that you produce, and it's kind of quite straightforward. But that's certainly not yeah, the only one. So I think just to say that while PRQL we've had some good uptake, but I think before that already, like there are a lot of alternative query builders, I guess they would be called. There haven't really been languages, and so I think they all kind of follow the same fluent API or this pipelined flow, where you start with your set of records or your tables, and you yeah, like you build up your query from there. And I think just one drawback with these has been so far that these are query builders that are sort of trapped in whatever language community they've been built in. So while I think they all have a very similar flow, it's they're in a particular language. So I think what we're aiming to do with PRQL is to create a common language that could be used in all of those, and then like leads to get serialized in a common way to the database. I'm here just some more examples of Python, Ecto, also like an Elixir and C#. So I think this is already the way most or a lot of SQL code is written actually in practice and in industry through these query builder front ends. Ibis is an interesting one because that takes the pandas API and then actually also serializes through different backends. So it's very similar to SQL, to PRQL, and they're using the SQL glot library. And I think it's a great project. It's my only sort of criticism there is that again it's in Python, so people in other languages are kind of stuck. So I think what we're aiming to do with PRQL is make it more general, as a general language that can work across different languages. And another interesting one is these computational expressions in F#, and I hope to maybe come back to that later. Which is computational expressions is actually just a clever term that F# has for monads, so that people can write monads and use them without being scared away by the M word. All right, so coming into pipelined queries, and why is everyone opting for these pipelined queries in the different languages? And I think from my perspective, a couple of key properties are these. One thing is the prefix property, as Thomas Neumann also mentioned, in that any sort of subquery from the beginning of the query is always a valid query in itself. Then by starting with the tables at first, you get the schema information upfront. So when you're writing code in your IDE, that also allows you to have auto completions and type information, so type checking. You have, I think another key aspect is you have local context, so that each step in the pipeline just transforms the pipeline up to that point. So as a human kind of reading it, you only need to keep track of the current context of where you are in the pipeline, which gives you more readability. And then I think for me, really the key part is composability and extensibility, because I think that's how we built abstractions and in any other programming language, which has kind of been missing in the data world. All right, so with that preamble, now let's see what have we done with PRQL. And as Omar said in the wire, if you come with the king, you best not miss. And we're quite aware that SQL's been around for a long time, but so far we've had some really good reception and uptake from people using prequels, and so I think we've been encouraged to keep going. And yeah, let me present you what we've got. So the P in PRQL stands for pipeline, and obviously so the main aspect is that we have a pipeline, which we have two ways that you can construct your pipeline. One, using the sort of Unix pipe symbol. So if you want to do kind of one-liners, you can write your pipeline like there, where we start from the left, pull records from the table A, do some sort of filtering operation, and then some selection. But most of the time, we actually just really write more complex queries. We also allow the new line character as a pipe symbol. So most queries kind of look like this, and then you get this top to bottom flow, like Julia Evans kind of pointed out, which kind of makes it just a lot easier for human to read, kind of in the same way English reads. I think most of this is fairly straightforward, so I'm just going to kind of point out some key aspects. The first thing is that we have transforms or functions. So so that makes the language like regular, in that if you have a filter expression here at the top, or then one further down after the group by, in both cases, you can use filter. There's no this distinction between where and having. And yeah, you can also, like, as long as the columns are compatible, you can move lines around, you can comment out lines. It's really just much more flexible for day-to-day work. Then the next aspect we've focused on is trying to make each sort of primitive operator orthogonal. So if you look at the group by here, which are highlighted, is that our group by operation partitions the data set into groups, and then it takes as a second argument another pipeline, and there you can really you can do quite a lot of things. So if you want to do just the traditional SQL group by, you can use an aggregate. An aggregate is a reduction that will always kind of reduce whatever it's given in its scope to a single row. But as we'll see later on, we can actually also do other things in the group, and you can do general transformations. And it follows this sort of split, apply, combine pattern that you often see in data science. And so because of the orthogonality, we get some nice invariants. So select, which is like a map operation, never changes the number of rows. Derive only adds columns. Filter, reduce the number of rows. So group partitions data set. Aggregate is the reduction and always produces a single row. And yeah, you see there. So I think you get some nice invariants. And with that, we get very few primitives. So in fact, we only have these sort of 12 primitive operators from which the rest of the language is constructed and built up. And that makes it easy to learn and also easy to retain, that you don't have to go to the documentation all the time to look at how is a particular thing implemented, or what are the parameters. So it kind of really makes the productive for practitioners. And so one small point on that. As you said, like it's a kind of like a data frame API, and I thought it's a really interesting paper here towards scalable data frame systems by was it Devin Peterson, and he did his PhD thesis on really looking at all the data frame operations, and sort of documented there's over 600 functions that are in data frame algebras, but you can actually reduce them down to these 15 operations. And then if you look at them, which ones relate to so relational algebra and which sort of deal with the columns, you get this split here. And, I think that's also just we cover kind of all of those. So it's just another kind of, I think that, we get a lot of generality with what PRQL implements. Right, then next is really, I think the main point is really that composable. So if you were paying attention during that list, you would have seen that there's no distinct keywords in PRQL. So how do we accomplish that? Well, if you think about it, logically, what is a distinct operations? You want to group by certain fields or attributes, and then take one per those group. So in PRQL, you can write the following, and that will produce a distinct. And in fact, actually, I got the query at the bottom by putting the query at the top into our compiler. And then I think last but not least, the key takeaway is really having higher order functions. And so we have a sort of very sort of ML functional style syntax. And so for example, here I define a take smallest function, which takes the first parameter, sort of number of items, and then a column to sort of sort by, and then as the last relation. And that's something worth pointing out, that in PRQL we've opted to have the input relation always as the last argument, and that was for allowing currying. So like currying in the functional sort of sense, or like partial application, so that you can carry on the early arguments and then still kind of get your main pipeline input as your last argument. So with that, you have this function here. We can say that on a data set of tracks, take this smallest 3 bytes, and obviously that sort of translates to this. So there's nothing much gained. But then the power comes in with the orthogonality, like I mentioned before. So if you're doing now, if you wanted to find this smallest 3 tracks by like milliseconds on a different column now and per album, then you can just take that same function and put it inside a group clause. And you can go and take that right now into the online playground, and that will work. And I challenge you, when I give these talks in person, I normally challenge people to come up with the equivalent SQL query. And it's obviously doable, but it's not straightforward. And another key aspect, which is our loop construct, which is really for recursive CTEs. And I mean, obviously that PRQL transpiles to SQL, so we can't do anything that you can't already do in SQL. But I think, for example, recursive CTEs are, in my experience dealing with other people, it's quite poorly understood. And they're really also not really recursive. So it's actually more of an iteration or loop construct, and which is kind of why we opted for the name loop in PRQL. And here's a sort of some Python code that demonstrates or illustrates what are actually the sort of semantics of recursive CTEs. And then just to give you a PRQL example, if you wanted to build up some sort of date spine from today until April Fools, here's a simple PRQL query with the loop construct, and that will give you these dates here. And if you want to look at the resulting SQL query, this is what it compiles to in our online compiler. So again, it's not introducing anything new, but I think by making the syntax simpler, I think it actually makes it accessible to more people that perhaps otherwise would shy away from using this in practice. And last, then next, we also have some ergonomics. And I think these again seem like small bits, but I don't know, maybe it's like in relationships, sometimes the small things are the big things. So I think these things that people really appreciate in their sort of day-to-day work. So we have dedicated syntax for date literals. We have string interpolation syntax for these F strings here, because a lot of what programming do is construct longer strings from smaller strings. We have this null coalescing operator, which is also taken from TypeScript. So because obviously we encourage a lot of nulls in our work, and you want to be able to easily substitute those. We can easily comment out lines, or also in numeral numbers, when you're dealing with large amounts, you can group your digits with an underscore, so which can prevent errors like confusing 8 billion with 8 million in kind of critical government operations or things like that. And I think these are all kind of micro features that we've learned from other languages over the last 40 or 50 years in programming language development, which I think would just be unfeasible to keep adding to all the SQL dialects consistently across the board. Then another sort of last key aspect is really testability. And because you can define functions in PRQL for transformations, so when you want to test out things like taking out to smallest example, it's easy to, here in our first line, I kind of just introduce some like literals, and then I can test my query on that and see that it's working as expectedly. Whereas in SQL you actually need to spin up a test database with the correct tables in place, etc., which actually makes testing very hard in practice, if not infeasible. Last, we've been also trying to solve the SQL dialects problems. So PRQL compiles to different dialects. There's some that are pretty well supported, others that aren't so well supported. And I think in practice it works pretty well. I mean, as sort of Victor pointed out in his talk, obviously we can't do anything about the difference in the underlying semantics. So there's still sort of buyer beware, kind of, you would do well to inspect the resulting SQL that you are getting the behavior that you want. But I think it does make your life a lot easier. All right, so with that sort of a tour, let's look at some examples, which I think also highlight some key bits. So first, if you go to our online playground, there's a well-documented example there, which you can probably just you can teach yourself PRQL from that in probably 5 to 10 minutes. And it's also easy to sort of use PRQL in Python or sort of Jupyter notebooks, and you can just pip install PRQL and then start compiling queries to PRQL queries to SQL there. But next, I've got some examples that I've prepared here. So I think this one is an interesting one that sort of highlights just two sort of aspects. So here I define two functions. One is %range function, which uses min and max aggregations to look at where do you rank in a range, and then also this add cumulative sum function, which takes an existing relation and adds an additional column. So if we look at the query at the bottom here, I apply the %range function to the total column, and then I just do some rounding to sort of display nicer on the screen. But the interesting thing with in PRQL is that our aggregations kind of fill up to the surrounding scope. So because this is in the global scope, these window function aggregations will be applied globally, whereas this add cum sum function I apply inside the group, and then it will actually do the cumulative sum per customer ID. I think so that will become clear, and I'll show you the output So this is the SQL that generates. So again, you can see here these for the percent rank numbers there, these are sort of over in the global, whereas for this cumulative sum, it applies to the partitions. So if I just look at the output set, here you'll see that, yeah, if we look at this percentile column, it's sort of applied globally, whereas this cum sum, you can see that it accumulates per customer and then resets at the next customer. So yeah, I think if you just wanted to go back here, just the example just shows you, how you can easily build abstractions to do some real kind of work. Then next, I have a sessionize function, which I think, for example, also like Jeff Shute in his pipeline SQL kind of showed that it's a common operation in sort of data analytics. So you want to sessionize your user events, and yeah, I'm not going to show you the sort of full definition of that here, but just to say that, given high order functions, we can apply sessionize and tell it by what custom ID you kind of want to group, and what gap you want to have, a maximum gap that we allow between events to still classify things as the same session, and giving you access to the same sort of abstraction that you have in any other programming language, where I can write this function once and you can reuse it in other places. Right. Next, I just have an example of some JSON. So like we're not going to have any sort of built-in JSON support in PRQL, but we have this little escape hatch built in, which we call S strings, or for SQL strings. And you can easily define functions which then sort of get substituted with sort of raw SQL strings. So if your target SQL dialect supports JSON functions, it's easy to wrap them in a PRQL function and then expose them here. So here I just sort of also build up like a JSON literal, and then just apply some examples here and run that in DuckDB, which you can see the output set here at the bottom. All right, so that's kind of like a bit of a whirlwind tour of PRQL. Now, I wanted to also speak about some ongoing and future work. So coming back to the Peterson paper earlier and talking about the data frame APIs, one thing that we've also noticed in the user feedback that we've been getting is that with a data frame type API, users expect ordered tables. So yeah, something, because data frames generally work on like in-memory data sets, they have an implicit order, which users often exploit in their work. And with PRQL, there's also a bit of an expectation of that, but obviously that is unsupported in SQL, or in SQL, because it talks about unordered data sets. So we've done some work on there, but that is we do have a couple of open issues on our repo around that. And I just want to point out there's a paper that I've found recently on language integrated queries, or LINQ, which derives or did a lot of work on how you can implement this consistently across different SQL dialects. So they first also describe your problem, and then I think propose some solutions. So I haven't gone through this in detail yet, but that's, for example, an issue that we're currently trying to address, with how to deal with these order semantics in a sort of pipelined flow. Yeah, so then just a bit of a teaser. Then some sort of missing features that we're working at the moment. So at the moment, we really started with this sort of an agile approach, getting working code quickly. And so in order to make PRQL responsive, we opted not to look at the target schema of where you're compiling to. But obviously we didn't, as a result, we are missing out on these sort of LSP completions and the skip awareness and the type checking. So I think that is something that we want to add. There is a fledgling module system, but no sort of packaging system yet for distribution. I'll come back to next, and then the next 2 points, I actually got additional slides, so I'll come to those. So the one is materialization annotations. That because of this functional flow, like if you look at things like DBT or Airflow, in practice, people have these DAGs of data transformations. And at the moment, the PRQL compiler, by you can define the functions, it inlines them all and produces one large query at the end. And I think I heard Lloyd Tab also on the Meloid talk saying that also they were looking at adding annotations for materializations. And I think that's something we also kind of want, that you can put in some sort of inlining boundaries, so at some point say, look, actually materializes the view and then refer to the view rather than producing a sort of gigantic query. I'd really like to also see an option type, as in my bio, like left joins, I think have bitten me more than enough. And if you have two tables which have non-nullable field, but after you join, obviously on a left join, then the fields on the right-hand side actually now are nullable. So I think if you had like an option type like in Rust and you can track the nullability, then the compiler could tell you, like, if you're doing a particular operation, actually be aware these fields coming from the right join, they could be null, and the null needs to be handled appropriately. I'd also really like to see other backends. So we compile to SQL at the moment, but I think actually it's a lot more general. So you could compile to data frames, AIM-lang, which is in Power Query or Power BI. Microsoft is actually a very nice system that deserves to be better known. And then I'll come to the last point if I have time. This is a universal DSL. So that's here. So if you look at so general like monad or like F# code, here's an example by Bartosz Milewski, and he was doing some operations on his file system, and it's on a blog post. And if you look at that, it really reads very much like PRQL code. And similarly in LINQ, which is a great system, but it's kind of trapped in this C# or .NET ecosystem, which also has all these same sort of primitives that you can apply to in-memory objects. And so, I think a pipeline language like PRQL or SenQL could really be much more general and actually be used as a DSL for the sort of list or sequence monad. And just to maybe some sort of related work, yes, Simon Peyton Jones from Haskell. I mean, done his work on list comprehensions, and this is sort of but hand waving at the end, so some ideas just here. There's no sort of productive work yet there, but I sort of believe that the universality of the relational model and the sort of this monadic kind of flow really comes down to the fact that in all languages we really structure all our data in product types, and perhaps this is an obvious point, but it's whether it's object-oriented or Rust or SQL, we generally have these product types of records, tuples, or whatever structs, whatever you want to call them. But that's fundamentally how we structure data. So whether that's durably persisted in a database, or we have these objects in your memory, you have collections of records, and it would be nice to just have one DSL that we can apply to efficiently work with those collections wherever you find them. All right, so with that sort of where I believe, I think PRQL is, or something like it is, would be a great addition to how we work with data. Where can you use PRQL today? And I think I'm kind of over time, so I'm going to just rush through these very quickly. So first of all, I'll show you we have this online playground where you can work with it right in your browser and try it out and look at what PRQL it compiles to. Just so there's a link. Then database, we've already seen increasing adoption of PRQL in a number of databases, ClickHouse, DuckDB, Postgres also has an extension. We have a VS Code extension. There's a number of language bindings, and we also have a CLI tool that you can use on the command line, and then pipe to whatever CLI tool you have. So pipe it to DuckDB or Postgres or whatever. And last, just a little bit about the project. And this is a bit of a dated slide, but the red line is pretty cool. We've seen sort of rapid adoption, or not adoption, but stars on a GitHub repo. I'm aware there's a bit of a vanity metric, but because we're an open source project, we don't track actually other usage. So this is the best indication we have. It's fully open source, Apache 2 license. It's completely volunteer driven. No one gets paid to work on this. All of the work has been done by people who've got full-time jobs elsewhere and just working on their spare time in the evenings or on weekends. And we're very serious about not monetizing. Our community, we've got over 10,000 stars, 74 contributors, 4 sort of main committers or maintainers that globally distributed, and a roadmap of more features. And we're really looking for more contributors, particularly like compiler developers that would love to have more people come on board, but not just compiler developers. I think also with the packaging system, and there's various features to add to the web interface. So I think any contribution is welcome. We really kind of would love for anyone to get involved and make this something that will benefit everyone. And with that, here's some final links, but I think that's my story. Thank you very much.
Taskmaster burst the bionic zit splitter. Breakneck speeds, we drown 10 pints of bitter. We lean all day, and some say they ain't productive. Could that depend upon the demon that you're stuck with?
So any up for questions?
I sit here contented with this cheese on toast. I feel the pain.
I have a question. So with PRQL, is there always a simple one-to-one translation when you're transpiling to SQL? Or are there certain situations where maybe there's multiple ways to translate the PRQL query into SQL? And how do you choose which way to translate it?
All right. Well, certainly, obviously, we always translate it in one way, and we make heavy use of CTEs. But that's why I kind of really try to highlight the language. Like I wouldn't, I don't think that our particular compiler, implementation. I mean, I think it's great, but it's not the be all and end all. I mean, I think ideally we would like to see this IR format, a sane IR or substrate or something, really. But it's I think the interesting question for you is there a back translation? That's a question I get a lot. So at the moment we don't have a good answer for that. So I think with the Google pipe syntax talk, Jeff really pointed out that there are a lot of existing SQL code bases, and we really kind of need something to on-ramp people and to allow you to import your SQL query. I think the best bet at the moment that I'm aware of is SQLglot from IBIS that I mentioned. They kind of can translate between, I think, over 20 dialects at the moment, and I've had some talks with Toby Mao there with trying to link in PRQL into their IR, and then I think we would have a two-way system from going from PRQL to other dialects, and also actually coming back to PRQL from there. But that's something we don't have at the moment. If anyone would love to see a contribution on that front.
Thanks.
So if there are any questions in the chat, all my screens are taken up here. I can't see if someone could just maybe point that out.
There is a question. Someone says, why no support for ANSI, ANSI?
Oh, there is ANSI. It's actually, I think, a default dialect. If you don't specify, it actually picks ANSI. Sorry, I left that out of my slide. But good question. But we do support ANSI SQL. Any other questions?
Feel free to unmute if you have any questions in the Zoom.
Otherwise, in the absence of question, maybe Sam, can you watch out for the question? I can just then maybe just show you some of the interactive what you can do in the
Oh,
other
there's one
Python.
question. Do you expect to support Spark? I'm not sure if this is SparkQL or Spark SQL. I assume SparkQL.
Not something I've looked at. I don't know how different their SQL dialect is. It's yeah, I think that would really be sort of up to a user contribution. Like if a particular team or someone would want to see it. I mean, if Databricks wants to contact us and add something fantastic. I think short of that at the moment, yeah, I think most of the maintainers kind of have a big list of things we want to get done. So I don't see me there, but yeah, I think it's open source. Please submit to PR.
Yeah, there's another question in the Zoom. Have you given any thought to spatial databases like PostGIS and their geometric predicates and functions?
No, I haven't given apologies. No, that's not something we've looked at. I mean, with that S-string functionality I showed, I think it would be probably easy enough to wrap existing functions and in whatever system you're using. So if you're using PostGIS to expose that easily, but no, it's not something the team has looked at. I don't know how to do this. Thanks. Okay, great. Then I mean, maybe if I still have 5 more minutes, I'm going to show you in the online set. Obviously, send questions this way, but I think what's quite nice and which just shows the sort of pipeline flow and that sort of prefix property is that here I have a sort of big query and I've most of it commented out. And if you use uncommon logical lines, you can see on the right-hand side the sort of SQL transforming as you go along. So you add a filter here, filter, add a join. And I think in practical work, so it's, as I said, like before, I think in practice, a lot of people copy and paste SQL code, but it's not easy with SQL because there's all this global sort of scope of the statements. So difficult to move things around. Whereas, here, like you can quite easily, pick things up and reorder them, etc. So I think it's just, yeah, maybe it's also just illustrates the applicability for practical interactive work where you trying to work with a data set and you want to see, okay, maybe I'll have a take 10 on there to make the quick, and then you kind of want to see, okay, if I take that off, how long does it take? I mean, yeah, it's just in practice actually this turns out to be very kind of useful to be able to work and disable or enable certain lines at different times. I had prepared a few examples here that just I mentioned, but yeah, I think they're probably covered in the presentation. So look, I think if there's no more questions, we can probably put it here. But I think obviously anyone that's interested, please reach out, and particularly on I think at the end, the sort of open-ended work with, could we make this like a sort of monad DSL for working with collections of objects or data more generally? I'd love to chat to more people about that as to what they think.
We have another question in the
Yeah.
chat. How about PRQL versus Google's Pipe SQL? Like, how would you
Yes.
compare them?
So I think I think the pipe SQL is great, and I think Jeff makes this point strongly that you want to extend existing SQL. I think I try to argue that I think just some of the small ergonomics that we have, like just slightly nicer. But I think, you know, some of the syntax, I mean, that really, yeah, it's a bit of, it's sort of, you know, in the eye of the beholder. Look, I think it's worthwhile, you know, that it's sort of nicer for us, but I can understand if people want to stick with that. I think one issue there also is that, again, that's then sort of in Google's ecosystem, and how portable is that really then to other dialects, and are they going to be supported the same way? So I think ultimately, I think something like having this intermediate representation, like say an IR or substrate, is probably still kind of the way to go. And then you could probably pick different front ends. You know, if the Google Pipe syntax works for you, then you can use that. If you like say QL, or then use that, or if you like PRQL, then you can use PRQL. But yeah, that would be the sort of dream.
Cool. I don't think we have any more questions. Oh, wait, sorry, there's
Yeah.
another question. What kind of changes do you expect to add in the future? This looks pretty mature.
Yeah, so I mentioned some of, I don't know if I should go back to these. So the module system, I didn't show it on purpose because I think the syntax might still change a bit. But you know, that we do have the basis of the module system. The type system, you know, that's yeah, we're looking at formalizing that. You know, we had some chats with that also with the NUS group, different backends. I think one reason I'm quite keen to see the different backends implemented, because then we could really test how portable some of these ideas are. So at the moment, I feel like it probably would port well to those APIs. But like things like loop, for example, yeah, I don't know. I think sometimes it's just it might be easy to overlook something. So I think implementing more backends, kind of want to just test out whether in practice that's really like a realizable version. And then yeah, more tests. Obviously, having more people actually use it. We have yeah, quite a number of open issues that yeah, that obviously sort of need to be fixed, some bugs, and you know, the occasional like regression, etc. So it's yeah, I think there's still a lot of work to do. So if anyone, you have contributions, and also if anyone wanted to sponsor like a big company, or like kind of any VCs to look at some offshoots of this, I have a number of the ideas. I would love to chat to people. You know, so at the moment, I'm still applying my trade elsewhere, but I'm quite passionate about this project, and actually, you know, see it get wider adoption, and help things build out with it. So please do get in touch if you have any ideas. So there was another, I heard something, there's another question. Different streams, that's kind of like a join, I think. Sure, exactly understand the question. I mean, it's one, I think it would have great application for kind of streaming systems, like Flink, or those things, you know, like, I mean, for example, on the Microsoft side, they got Custo, which is very similar, or at least sort of, you know, semantically, or there's this pipeline flow. So I think for streams, yeah, it would be actually quite a good application also of PRQL.